Okay, so now we are going to switch our discussion into the second half of this chapter on buffer and titration, and that is on the concept of titration. Now, most of you have done some type of titration in prior classes, whether it's in Chem 10 or Chem 11. But what we want to do here in this class is really go beyond the experimental part of titration and explain how we can use the skills we learned in the prior chapter of calculating the pH of acids, bases, and salt, as well as the skill we learned in this chapter of calculating the pH of buffers to help us understand how the different pH value that we observe during titration actually happen. Before we do those calculations, the first thing I want to do is start with just giving an overview of what titration is. It's an analytical technique we use when we want to determine concentration of an unknown species. So if we're interested in concentration of an acid or a base, then we do an acid-base titration. It might also be for other types of reactions, but the most common one that we do in the general chemistry context is acid-base titration, and this discussion is going to focus on acid-base chemistry. We're going to have a solution where we don't really know the concentration of, and we would put that usually in a flask like this, and that solution is going to be called the analyte. And then to that solution, we're going to add a solution that we know the concentration of. That solution that's in the burette is going to be called the titrant. And for us to know that the reaction has finished or has reached what we call the neutralization point or the equivalence point, we're going to need to add a solution in this flask that would change color when that condition is reached. And that's what we call an indicator. I just mentioned the equivalence point. That's when you have exactly a stoichiometric amount of the acid and the base. So for example, if you have HCl reacting with NaOH, if you have 1 mole of HCl, then the stoichiometric or equivalence point would be reached when you have added 1 mole of NaOH. If you're reacting sulfuric acid with NaOH, the stoichiometry between sulfuric acid and NaOH is not 1 to 1, but it's 1 to 2 if you balance it out. So if I have 1 mole of sulfuric acid, I'm going to need 2 moles of sodium hydroxide to completely neutralize all the acid in sulfuric acid because it's a diprotic acid. And as a result, the equivalence point in these two titration is not going to be the same. It depends on what kind of acid and what kind of base you're using. Now, the equivalence point then is an important idea. It's not necessarily when the number of moles of the two species are equal, but it's the point when the number of moles are stoichiometrically equal. So we need to take into account the stoichiometry between the acid and the base. And the last point I want to mention is a term called the endpoint. And this refers to the point when the indicator changes color. So the endpoint and the equivalence point are not the same thing, although we try to pick an indicator whose endpoint is as close as possible to the equivalence point so that it tells us that we've reached the end of our titration. But just keep in mind that those 2 points are different things. They're for 2 different events. So the picture of a titration that you have seen before and you have done in prior classes looks something like this. You have your titrant in a burette, your analyte in a flask, and as you can see here at the start, the flask is clear. And then as we add the titrant, we see a change in color. But once we swirl that flask, the color disappears. But eventually, when you keep adding the titrant, when you reach the equivalence point, then that color will stay. This particular titration would be an acid-base titration using phenolphthalein as your indicator. So what we're going to do is spend time talking about 2 different types of titration, something I call strong titration, which just means that you're titrating a strong acid with a strong base or vice versa. And then we'll spend some other time talking about weak strong titration, which is the titration of a weak acid or a base by the opposite species. But in this case, the opposite species is a strong base or a strong acid. So that second type of titration, the weak strong titration, is going to be more complex. So I'm going to start with the strong titration. And the best way to go about discussing titration is really to do calculation. All the calculations that I'm going to do and I'm going to show you here are really calculations you've learned in your prior chapter on acid-base equilibrium, as well as some buffer calculation, which is something you learned earlier in this chapter.